get ready for the next talk here, which is by Rich Harris on dismantling the barriers of entry. I think this is actually a really natural segue to Taylor's talk because the web really succeeded because it was democratic, because it was easy for people to put together sites initially, because it was all about straightforward markup that people could use, simple protocols that were easy to implement. And as time has gone on, the web has gotten increasingly more complicated, and it's become a very specialized domain again. And so things like web components, I think, take us back towards a more democratic web, and that's part of what Rich is going to be talking about as well. So with no further ado.
Okay, thank you. So this talk is called Dismantling the Barriers to Entry. And I'm not going to be talking about the social barriers to entry. I'm not going to be talking about gender imbalance. I'm not going to be talking about ageism. I'm not going to be talking about hiring practices that emphasize cultural fit or anything like that. Those are all big, important issues, but they're questions that I don't have the answers to. What I do want to talk about is the barrier that you face after you've overcome that first barrier, which is that programming, frankly, is too damn hard. Now, there's a certain genre of conference tech talk that you're probably familiar with. The speaker, rather like me, stands in front of an audience, rather like you, speaks in generalities about some nebulously defined propositions, such as that programming is too damn hard, before mentioning halfway through the talk, almost as an afterthought, that they've been working on a tool or a library that happens to solve this problem, and then the rest of it becomes a sales pitch, and it's kind of like a bait and switch. I'm not going to do that. Instead, I'm going to do the sales pitch first, and then I'm going to get on with the nebulous generalities. And the thing that I'm selling is this. It's called Ractive.js. It's a user interface library that's used around the world on everything from e-commerce websites to real estate, games, news websites, and so on. And it's something that I believe makes making web development. I believe that it makes making rich interactive web applications far simpler. First, I need to describe a little bit of the context in which it arose. I'm a journalist at the Guardian newspaper. I work with a team of 3 others at our office down the road in Soho. And the difference between us and other journalists is that rather than predominantly writing English, we mostly write JavaScript. These are some of the projects that we've built recently. In the top left, we have an element from a multi-part investigation into the immigration crisis. In the top right, we have part of a data visualization showing the discrepancy in voter rights from one state to the next in the US. In the bottom left, we have an epidemiological simulation designed to show anti-vaxxers just how stupid they are. And then in the bottom right, we have the time from a month ago that we live translated President Obama's State of the Union address into emojis. So the projects that we do are terrifically varied. They're different in terms of tone, in terms of audience, in terms of structure, in terms of the technologies that we use. And as Taylor alluded to in the framework versus library distinction, there isn't really a framework that could capture all of these different things that we're trying to do. Having said that, there are a few recurring themes in our work. It's very visual. There's lots of animations and transitions. There's often a lot happening on the screen. We have SVG mixed in with our HTML. We don't get a brief. We get an idea. And we're often doing background research into a story that's changing under our feet at the same time as we're building the application. We don't have these discrete development stages from building a prototype to building the finished thing. It's a continuum. And that means that your prototype has to be as robust and performant as you intend your finished app to be. We don't control the page. We have to inject our content into a potentially hostile environment with ever-changing CSS. We don't know if it's going to be on a desktop or a mobile, in a mobile browser, or in a web view inside our app or Facebook's app or something else. And we don't want to use iframes because that makes everything constricted in a way that we don't like. And we're often under extreme time pressure. If you think about a typical agile sprint, it's what, 2 weeks, 4 weeks? 4 weeks is not sprinting in the news business, it's limping into irrelevance. And so we work under extreme time pressure. And the thing is, the people who do this job, the people who work on teams like ours, typically they're not ninja rock stars. They're journalists who have taught themselves how to program because they believe in the power of web technologies to enable new forms of journalism. It's a powerful idea. But a lot of these teams have found that building high-performance, flexible, responsive applications under extreme time pressure is actually kind of difficult. And so a few years ago, I was thinking about this problem. I was thinking about how we might try to structure these apps more efficiently. And there were a lot of frameworks out then. There were not as many as there are now, but there were still Backbone was at the peak of its powers, and Angular was the hot new thing on the scene. And they did a lot of stuff. They do a lot of things like persistence and model validation and routing, or routing as you say over here. These are important things, but they don't really help us do our jobs when we're building these very complex visual apps. And it seemed to me that a lot of what we were doing was manipulating the DOM into a particular state. I mean, that's a lot of what web development is manipulating the DOM into a particular state. So I thought, if a tool could help us build this stuff, what would it look like? It turns out we already have a really good concept for describing the DOM in a particular state, and that concept is HTML. Now, you might think that HTML is a lousy paradigm for building modern web applications, and you could be right, but that's not the point. The point is that the relationship between HTML and DOM is one that's very clearly understood. So much so that when you inspect the DOM in your DevTools, it's rendered as if it were HTML. It's not HTML, it's DOM, but it looks like HTML. These two things work together hand in glove. So maybe templating is the solution. Template languages, very popular, there are many of them, and they all work along some lines that are similar to this. You have some markup where you have placeholders for where you intend to put your data. And then you'll give it some data, like that. You have your hello world example. Then you take that rendered HTML and then you do node.innerHTML equals my new HTML, and hey presto, you have a web application that is rendered from your template. And that's all well and good, you can turn that into hello applicative. And if I can spell at least. And you're able to update your page and it still resembles the template that you originally gave it. But there are some problems with this approach. But this, by the way, is what's happening under the hood. So I'm using handlebars here. This is a function that handlebars compiles so that it generates your string so that you can inject it back into the page. There are some serious problems with the string templating approach to web development. So here's a simple template. You can look at it and you can guess what's going to happen. I have some event listeners that are listening for when we change what's in our input, and it's going to update the value of name accordingly. So, what's your name? Well, world. Didn't work. It didn't work because as soon as we generated new HTML and put it into the page, that input, which was focused, got destroyed and thrown away. So what we're going to have to do is we're going to have to say, was the input focused? Re-render. If it was focused, refocus it. So we can do that. Let's try again. Now it's typing backwards. And the reason it's doing that is because the input knew where the cursor position was, and when we destroyed it and put in a new one, it didn't know where the cursor position was. Reset it to 0, so everything happens backwards. And, we can, of course, maintain the cursor position. We can look for the input.selection start, I think it's called, and then, you can do that. But you've had to jump through a lot of different hoops to get that to work. And you're all looking at that thinking, well, yeah, of course. I mean, I would never do that. That's stupid. I wouldn't have the input in my template. And I know that you wouldn't, because you're all experienced and, frankly, devastatingly attractive developers. But a lot of people would look at that and they would think, yeah, of course that's going to work. It seems like that should work. It's only because we've got Stockholm syndrome from being web developers for so long that we're not surprised by that. Another problem is performance. So here we've got a table with 1,000 rows. And again, you're thinking, well, I wouldn't have a table with 1,000 rows all at once. I'd use some kind of virtual scrolling mechanism or something. And, frankly, good for you. But for most people, this is a pretty good, pretty sensible, pretty easy to understand way of getting some data into a page. We have, up there on the left, we have some table headers. And then down there, we're iterating over our rows. And we're just printing out the data one row at a time. And that works. We've got our 1,000 rows of data. There's a guy here called Cloud Colon. This is what happens when you automatically generate JSON data. And if I click on one of these headers, then it's going to resort the page. It's updating in about 25.4 milliseconds. It really undermines my demo, to be honest, because when I was doing it on my machine that wasn't plugged into a projector and it was on this Retina display, it actually took a lot longer and it was blowing my frame budget by a huge amount. But the point is that it takes that amount of time no matter how much you're actually changing in the page, because you have to regenerate all of this HTML, which means that you have to take all of the old DOM out of the page, get it garbage collected, generate the new stuff, put it in, and that's just slow. It takes a lot of memory and it's slow. And if you change just one piece of data, so if we look at this guy's age, you probably can't see it because it's tiny, but the guy in the top row, his age is 30, and if I change his age, then you'll see it's still taking about 25 milliseconds a pop. Now, what most developers do in response to this sort of thing is they don't have a table template, they have a row template. And so you'll have 1,000 individual views that instantiate a view class that you've designed for this exact purpose, and that view class will handle its own rendering, it will handle its own updating, it will handle its own events, and it'll communicate with a model. And the view and the model will fire events at each other, and they'll talk, and the page will update, and it'll be a lot more performant. But look at what we've done. We've taken this perfectly simple idea where we had an array of objects and a template, and we've turned it into this Frankenstein with all these events passing around here and there. And the trouble is that event-based systems that are based on this idea of passing messages around, they become brittle after a while. In my experience, opinion klaxon, they become brittle and they become hard to manage. Your stack traces become chaotic, and it's really hard to maintain, because when you come back to this app in a few days' time, you have to remember which objects are capable of firing which events and who's listening to them and what kind of data is getting packaged with those events, and it just becomes chaos. We used to talk derisively about jQuery spaghetti. Remember that phrase, apps that are built out of jQuery spaghetti? I put it to you that we've replaced jQuery spaghetti with MVC duct tape. This is Jamie Heineman on a duct tape sofa, and he's afloat for now, but he'd be a lot happier if he just built a boat in the first place. So this is what I call string templating. It's slow because you have to continually generate new DOM. It's slow because you have to keep garbage collecting the old DOM. Event handling sucks. Like, either you have to use event delegation, which you can't always do because some events don't bubble, or you have to keep reattaching and detaching event listeners. And the DOM contains state, like that input that we saw. When you type into the input, you're changing things that aren't reflected in your program, they're just reflected in the DOM, and you need to account for that somehow. And it encourages this MVC duct tape phenomenon. Now, there is an alternative to string-based templating, which is DOM-based templating. The idea is that you have your template actually there in the DOM rather than in a string. And so we have a sample of what a DOM-based templating language might look like. It's not a real templating language. You may have seen similar constructs in certain DOM-based templating systems. In particular, note the lol repeat equals photo in photos and the lol source equals photo.source. We're actually mixing two things here. We're mixing two ideas. We're mixing a description of this particular element with some control flow that's telling us how many times that element is going to be rendered. Some people might put that repeat directive at the start of the list of attributes. Some people put it at the end. I put it in the middle. And it means that it's quite hard to understand when you're reading through a template exactly what is supposed to be happening here. You're essentially complecting control flow with content. And the only reason that you could possibly think that that was a good idea is because if you had no choice. And that's the case with DOM templating, right? Because if your template lives in the DOM, it has to be valid HTML. And it turns out there are lots of times when you can't have things like a handlebars each directive wrapping the thing that you want to iterate over. In tables, that won't work. In select buttons, that won't work. All of these times, you're limited by what is valid HTML, and so your template language isn't very expressive. It means that you have to have all these crazy server-side rendering hacks. If you want to deliver HTML to the browser without it all getting rendered on the client, then you have to have Phantom.js or JS DOM running in Node, something like that. And it all gets kind of unwieldy. And you have broken pages, right? You have this, you've all heard of flash of unstyled content. Well, this will give you a flash of undatabound content. And that we have to have lol source instead of source because otherwise we'll get a network request for something that doesn't exist. And so there are lots of hacks and works around that you have to implement in order to avoid those issues. The new template element that Taylor was talking about does help. It does solve a lot of these issues. But fundamentally, the DOM just isn't a place to store your junk, right? It's I don't think that it's appropriate for the DOM to be a template delivery mechanism. And this code at the bottom here, this is the sort of thing that you have to write if you actually want to use template elements. And it's exactly the sort of code that I've spent the last few years trying desperately not to have to write. But what if you could get all the expressiveness, the ease of writing, the ease of reading, the malleability of string-based templating languages without any of those downsides? Well, that's what Reactive does. It takes a string template, it parses it into what's called an abstract syntax tree. I'll show you an example of that later. And then it constructs a virtual DOM which has bindings to your data and which will update intelligently when your data changes. And because I've said the words virtual DOM, I have to say that this is not the same as the React virtual DOM. The React virtual DOM is a snapshot of your app at the current moment, and React compares it to the previous snapshot to figure out what's changed. Reactive doesn't do that. The virtual DOM is a persistent object which knows about the real DOM, and that persistent object changes over time to reflect the state of your application. So they're two almost diametrically opposed approaches, but they have the same goal, which is to do the minimum amount of DOM manipulation possible. So what happens when we do that? Well, this is the exact same template, and we've actually removed some code because we don't need it anymore, and I can type in there and it just does what you would expect. I've actually disabled those two buttons there because, can you see those? Yeah, you can. Just because the screen is warped, I couldn't tell if it was off the edge. And similarly with the with the table, I hope to God that this is going to work on this screen. It's actually slower. Well, this is what happens when you try and do a live demo, ladies and gentlemen. Ordinarily what happens is updating using the virtual DOM is a good deal quicker. It's particularly quicker when you're not updating the whole thing at once. Updating 1,000 rows is Reactive's worst case scenario, but if you only update one thing at a time, then, so that age is changing in the top row there, then it's orders of magnitude faster than the alternative typically. So, it's time to do a little bit of live coding. Wish me luck. So this is what it looks like to actually use Reactive. We'll create a new Reactive instance, and we're going to tell it to render into that element on the right, and we're going to give it a template, and we're just going to execute that. And it does exactly what you would expect. It's just putting that HTML into there. And if we replace that string with some data, and then put that data in, it does exactly the same thing again. The fun part is that we can now change that data on the page, and just to prove that it is not destroying perfectly good DOM, I'm going to make that H1 element red and give it a font that everyone loves. And if we now change the data, it'll use the existing DOM that's on the page. It won't trash it and generate new stuff. And what's happened here is we've moved from a DOM-centric API to a data-centric API. And that's really good because we can now change things about our application that would ordinarily cause some quite painful refactoring. So we could change the template and use paragraph tags instead of that H1. We could reuse that data in other places, and we don't have to have another element somewhere. We don't have to target it. We don't have to say, you there, you need to update as well as that guy. It's not the case anymore because we're using a data-centric API. It means that you can build apps more efficiently, and it means that they're more robust. So if we take that hello world example and try and turn it into something useful, it's the late 90s, and we're going to build a web portal, and it's going to be mega cool because that's how people talk back then. So we're going to start with a simple template, hello name again, and we're going to have the time of day, and then we're going to create our instance. We're going to put the template in there, give it a name, say the date, and we're going to create an interval. Once a second, it's going to update the data. And it works. Doesn't look great because we're just using the dates to string method, which generates this fairly clunky formatting. So what we can do is we can bring in a library. There's a library called moment.js, which is really good if you ever have to work with dates. and that's going to format the date for us. And one way to do it is just to write it here in the loop. We'll just say, we'll do it that way, and it looks a lot better already. But that's not great because we're not using the date object anymore. We're using a string, and strings aren't very useful. It's hard to manipulate strings in the ways it would like. We can't say, I want to know how many hours are in the day, or I want to adjust the time zone or something. So I'm going to do something that you're probably going to take a dim view of. I'm going to put the logic up here in the template instead. And just add moment to this data object so that Reactive knows about it. And it continues to work. Now some of you are thinking, what's he doing? He's got logic in his templates. He's violating separation of concerns. Who's familiar with this phrase, separation of concerns? Yeah. I want you to take a moment and think about how nonsensical that is, the separation of concerns argument for logicless templates. What part of my app is concerned with that particular textual representation? Only that component. And so separation of concerns actually demands that I have logic in my templates, not hidden away somewhere. You shouldn't have business logic in the front, that's true, but you can make the case just as forcefully that you shouldn't have presentation logic in the back, and that's what this is. And when we do things this way, we can make other changes. When the designer comes along and says, oh, no, we shouldn't have the whole thing in bold, we should have the day and then the time separate, we can do that. It just works. And we can make that change with an absolute cast iron guarantee that it's not going to break anything else in our app. We don't need to smother our application in tests to make sure that we're doing the right thing by making that change. And when you're building things under time pressure, that kind of confidence is an absolute godsend. Now, I want to add another element to our welcome page. We're still going to be using the datetime object, but this time we're going to create a clock out of SVG. So var clock equals new reactive. It's going to go in that demo element again. Template from the left hand side. Oh, by the way, this is ES6 syntax. So in ES6 you don't have to do template : template. You just do template. Really nice. And we're going to have an ending tool again, just to update things. And so we're going to create an SVG, give it a coordinate system, move our group into the middle of there, and then we'll create a white circle for the clock face. And then we're going to add the hour hand. It's just going to be a line, and we're going to rotate it by 360 degrees divided by 12 hours is 30 times the date time get hours, and then we're going to take account of the minutes as well using some similar logic, and we've got our hour hand. Do the same for the minute hand. Same sort of thing, a line, give it some rotation. The logic's right there in the templates because it doesn't need to be anywhere else. And we have our minute hand, do the same for the second hand. And you get the basic idea. This time, going to add a little counterweight at the back because that makes it look a bit more like a real clock. And so in a fairly few lines of code, we've got a functioning clock on the page. It's updating, we're not having to destroy DOM, we're not having to deal with SVG DOM APIs or anything like that. It's not perfect. I would like to have some markers around the edge to show what minute it is. And we're going to have some minor markers every minute and some major markers every 5 minutes. So we'll just create some arrays, and then in our template we'll just iterate over those like so. And we can make whatever kinds of changes we want to make because it's just a template. Anyone can come in and read it and see, oh, the clock face, I want that to be a different colour. So someone give me a colour. Purple, great choice. We can make it purple. And there's nothing hard to understand about what's happened there. And if you compare that with the kind of code that you would normally have to write to do something as basic and elementary as this, you would have to have some render logic and some update logic that is separate from each other but at the same time tightly coupled to each other. You'd have to store loads of references to loads of DOM nodes, and it would just be kind of ugly and chaotic after a while. Whereas this, any designer can come in and make tweaks. They can say, do you know what, that should be 41.5 instead of 42, and they can just make those changes without needing to understand the code, without having to form a very complex mental model of what's happening in your app as you go about updating the DOM. Now the chances are, gonna make that white again. Chances are we are going to want to use this clock elsewhere in our app. So it'd be nice if we could turn it into a component. So we're going to do that. We're going to turn it into var clock equals reactive extend, and just by the way, the CSS is encapsulated. If we give it some CSS, then it will transform it in such a way that it doesn't affect anything else on the page, which is a really useful thing when you're building things with other components, with other people. You don't need to namespace everything aggressively. CSS is really hard to work with when you don't have encapsulation. So that's an instance of our new clock class. We're not setting the time again every second anymore, so it's static. If I run it again, then the second hand will update. And that's basically that. If we then go back to our original homepage, and so I'm going to start typing a bit quicker. This is holding me up. And so now we're registering the clock component, again using ES6 syntax, and that means that we can now use it in the template. And that's nice and easy. It's neatly encapsulated, and we can do things like, okay, I actually cheated. I added some extra logic which makes it support time zones. So now we're going to have one for each of the locations where the Guardian has an office. And it's exactly like the web components idea of encapsulation. There are some important differences. We don't need polyfills. We don't have a single namespace. You can actually encapsulate things within your own private namespace. And that datetime attribute, you can pass through data that doesn't have to survive being coerced into a string, which is what happens when you set attribute on a DOM node. So I'm not bashing web components. I love web components, and you can use web components inside your Reactive templates. But there are some important differences that you need to understand. Now, at The Guardian, we've taken this idea of components to its logical extreme. We actually write our applications almost entirely out of components. This is a screenshot of part of my Sublime text sidebar when we were building a recent project. And you see all of these HTML files. These are what we call component files. And they have a syntax which is similar to the HTML import syntax, which is part of the web component spec. So up here, we're calling in another component that we want to use. Then we have a template. All fairly basic handlebar syntax stuff. We've got that other component that we wanted to use. We're passing in an attribute there. Down here we've got some style, some CSS which gets encapsulated, and then at the bottom we have some behavior, some JavaScript. And because it's just an HTML file, and in HTML you can have style tags and you can have script tags, the syntax highlighting just works and everything kind of behaves as you would expect. And it's really nice. And it means that we can do things like this. So this is that component actually being used on the page. This is a project that we did last week for the Oscars, and it means that we can reuse things in a very easy, declarative fashion throughout our applications. Now, it's a very heretical way of working, but it's also extremely familiar, because when you started to do web development, the chances are you had a blank HTML file and you had a style tag at the top and you had a script tag at the bottom, and you just put everything in the body tag or in the style tag or in the script tag, depending on whether you're writing HTML, CSS or JavaScript, and everything just kind of works and you were productive and happy, because the relationship between the markup and the CSS and the CSS and the JavaScript is very clear. It's very obvious what links to what, and people can form a mental model about what's happening fairly straightforwardly, because everything is in the same kind of space. And as humans, space is such an important mental concept. When we're working in a single space, we have it's easy to understand the relationships between different things. And you were happy doing that until someone came along and started telling you about best practices, right? You had to keep your JavaScript in a separate file and your CSS in a separate file, and then all of a sudden your code, everything's still coupled to each other, but it's all kind of separated, and it makes it harder to refactor and grow your application, because you need to, if you change the class that you're using to select an element in your markup, then you have to also change it in your JavaScript, and it becomes a little bit complicated. But you know, best practice is best practice, and we all must go along with it. This is another best practice that's crept in since the good old days of DHTML. On the left, we have a div with an on mouse move event handler. And it's pretty clear from looking at that template that when you move your mouse over that div, something is going to get redrawn, right? Because it literally says mouse move equals redraw. And that's cool. And then in your JavaScript, you just got a redraw function which does some stuff. That's not entirely cool, because for that to work, your redraw function has to be in the global namespace, and that's kind of a no-no. So what we do nowadays is we'll give that div a class name instead, and then in the code we'll look out for that class name, and then we'll add an event listener to it. And obviously that's better because we're not putting stuff in the global namespace that doesn't belong there. But you've got to admit that it's a little harder to understand what's going on. You look at that box in the top right and you're like, I can't tell if that class is there for JavaScript purposes so that we can select it, or for styling purposes. You can't tell without reading the whole app and figuring out what's going on. And I don't know if the person who wrote the JavaScript is going to use document.querySelector or document.getElements by class name or whatever. So you have to really read through the code and understand at every stage what is happening in order for you to be able to modify this application. But if, let's say, we were building a library that was creating a virtual DOM so that we could bind data to the real DOM, maybe we could do the event handling at the same time. So that's what we're going to do. Write some code, write a template over here, and it's going to have on -mouse move equals redraw, and then we're going to have some SVG code here. Can anyone tell what this is going to be yet? And then on the left, we'll write some code that actually instantiate this. So we're adding our redraw function to the Reactive instance. And so it's not in the global namespace, this is just something that's going to get called every time the mouse move event happens. And when we execute this code, we've got some eyes that follow the mouse around. Let's give this guy some eyebrows. That's better. Now this is kind of the best of both worlds, because we're not squirting anything into the global namespace, everything's neatly encapsulated, but it's also super clear from looking at the Reactive template that mouse move means redraw. It's literally an equivalence. I call this the wisdom of the ancients, right? We in the web development community are not good at keeping alive the wisdom of the ancients. We're obsessed with new techniques, new tools, things that are shiny, and we discard all of these tried and trusted techniques. Some of the original design decisions that have been glommed onto the web platform over the years, some of them admittedly terrible, but some of them really good and really help you to make it clear what you're doing in your applications. And that's the thing that Terry alluded to. Back in the day, writing code for the web was simple, and it was actually kind of easy, and things have grown a lot more sophisticated now, but we've discarded a lot of the wisdom of the ancients. And there's a cost to that, which I'm going to talk about. First though, I'm going to give you a little demonstration of what's actually happening when you instantiate a Reactive instance and when you interact with it. So on the left we have our Reactive code, on the right we have the parsed template which it uses under the hood. So if we do a plus b equals a plus b, you can see it's generating a representation of that template in a form that can be serialized to JSON. So you can do this on the server and send the template to the client already parsed if you want to avoid having to do that, although it's not expensive. And then it creates what we call internally a view model and the virtual DOM. And the view model is actually more than its name suggests. It's a place to store your data, but it's also a way of interacting with that data and making it observable, even though it's just plain old JavaScript objects. If you're using something other than POJOs, if you're using backbone models or RX observables or promises or something like that, then you'll be able to find an adapter plugin for Reactive that allows it to speak that particular language. And it has a number of other things besides. It allows you to observe the data as it's changing within your application. So when the virtual DOM gets constructed, it sees the A tag and says, view model, I depend on A. And then it sees the B tag and says, view model, I depend on B. Would you notify me when those things change? And then it sees the A plus B thing and says, by the way, I need you to compute this value for me and tell me when it keeps updating. It doesn't do It doesn't do evaling to do that. It's a slightly more sophisticated system. We don't allow things like the new keyword in expressions. We don't allow assignment operators. We don't allow the function keyword. All of those things that could give rise to XSS vulnerabilities, performance concerns, pernicious side effects, anything like that is just not allowed in your templates. But you can have any other legal JavaScript and it will just work. So from there, if we were to change the view model by doing Reactive.set A40 B2, it would look at the data it already has. A has changed, B hasn't, so it knows that A has changed, and it's going to quickly figure out that A plus B has also changed as a result. So what happens as soon as we call Reactive.set, a batch of operations is created. The view model is then notified about the change. It identifies the dependence that it has. The virtual DOM members that are depending on that are then told that they may need to update, and if that's the case, they add themselves to the batch of operations, and then at the end, the batch of operations is flushed. The reason that they don't update themselves automatically is because you might then have to touch the DOM more times than you actually need to. For example, if you had an attribute with more than one mustache tag, it would cause multiple updates. So everything gets batched in an efficient manner. Importantly, this all happens synchronously. You will see some benchmarks out there on the World Wide Web trying to convince you that an asynchronous approach is better. Rather than changing the DOM as soon as you have new data, waiting to see if any other changes come in and then doing it on a request animation frame or something like that. And the way that these benchmarks work is they'll toggle a checkbox like 100 times in a millisecond or something like that. Personally, I can't do that. So I don't consider those benchmarks to be an accurate reflection of the performance benefits of asynchronous rendering. Now, your program will become more complex if you have an asynchronous rendering model. If you need to do things like query the DOM after you've set the data, for example, to measure an element, to reset some scale or something like that, your code becomes much harder to reason about quite quickly. But you can trigger asynchronous transitions with your data changes. For some reason, my demo is broken. I will have to investigate after the fact. But because transitions can happen asynchronously. In fact, I'm going to refresh the page because this shouldn't be happening. Those transitions can happen asynchronously, and that means that there we go, everything's working again. Reactive.set will in fact return a promise which fulfills when those transitions are complete. And so, if you do something like that, you can chain your animations together in this very declarative, easy to understand way. And that means that you can come up with some quite neat effects without having to have a full-blown animation library and lots of related concepts expressed in your application. Right, so that is the end of the live demo portion of this talk. Hopefully I've piqued your interest a little bit in Reactive and convinced you that even though React is genuinely a wonderful thing, it is not the only game in town. In fact, the idea that Reactive has of a virtual DOM and of the way that data mining works within Reactive, when it came out, it was fairly novel. But since then, Meteor have adopted a very similar system. Ember are in the process of adopting a very similar system called HTML bars, which is going to replace their handlebars implementation. And so these three teams have independently come up with a very similar concept, which to me says that it's a concept that makes sense. It's actually a sensible way to build applications, and it has a lot of benefits, some of which hopefully I've shown you. What I want to talk about really is this idea that web development has got too complicated, and that what we've done is erected these barriers to entry. Now, one of the big promises of the digital revolution was that of disintermediation. The idea was that we would use the power of the network to get rid of, to connect buyers with sellers, lenders with borrowers, artists with their fans, people with fetishes to other people with fetishes. And we did it. We managed to do all of those things. But there's one group of intermediaries that we did not get rid of, and that's ourselves. If you want to use web technologies to create interactive applications, if you're a journalist or an academic or an educator or a scientist an activist, an artist. You kind of can't. You have to go through us because we hold the keys to the Magic Kingdom. It's really hard to build web applications as things stand. Now we have extraordinary power. Those of us who work in technology, we have extraordinary power. We have extraordinary economic power because there is an insatiable demand for software. Software is the new intermediary, if you will, and we're the ones who create it. You know, we joke about how annoying it is to have recruiters call us up and offer us high-paid jobs doing something that we'd probably be doing for free anyway. Meanwhile, other people's jobs are getting automated into oblivion. We also have extraordinary social power because we are the people building the systems and services that form the fabric of modern society. And the assumptions that we have about the nature of identity, about the right to privacy, about which industries deserve to be disrupted, those ideas inevitably find expression in the things that we create. And other people's ideas, when they come to us, are filtered through that lens. Now, do we really imagine that this tiny sliver of humanity, tiny, vastly unrepresentative sliver of humanity, is capable of faithfully representing the needs of the rest of society? It's mathematically impossible. Even if you don't think that Silicon Valley's outsized influence on our culture is a bad thing, then it's mathematically impossible that we're capable of wielding that power in society's best interests. We should all want a world in which everyone can participate in the web as a creator as well as a consumer. Not just publishing text and images through other people's platforms, platforms owned by people with values different to theirs, but people being able to create rich, interactive web experiences. Now, of course, the stock answer is they should learn to code. God, how many times did we hear people say, you know, if you want to participate in the new economy, they should learn to code. Literally 2014 was the official Learn to Code year. And you know, the Learn to Code movement is great, and I don't wish it any ill whatsoever. But most people's Learn to Code experience goes a little bit something like this. They'll sit down in front of an interactive tutorial, and they'll learn about variables and data types and for loops, which is a little bit like learning French by learning how to conjugate verbs and pluralize nouns before you've been exposed to any vocabulary or experienced any French conversation, right? There's this huge focus on being able to type syntactically correct code and very little focus on being able to read other people's code, comprehending code, being able to form the mental habits that allow programmers to see the world in such a way that they can model it through code. But never mind, because you have these cute characters that will pop up and say, no, you missed a bracket there, and it'll fix your code for you. And you get to the end of the tutorial, and you'll feel that this is something that I can do. This isn't so hard. This isn't superhuman. This is just text. I'm just entering text, and the browser's executing it. Surely I can go and build Gmail now. And a lot of people, you know, they sit down after they've finished their Learn to Code experience full of boundless enthusiasm for the things that they're going to build, the things that they're going to create, and it's wonderful to see. And then they start typing into their blank HTML file, and they suddenly realise that without the handrails, it's kind of like the first time you went 10-pin bowling without the rails at the side. You know, gutter balls everywhere. Your code is chaotic and buggy, and you're not sure what's going on. And things that feel like they should be really straightforward, right, representing state consistently throughout an application, turn out to involve a lot of really difficult, repetitive, hard-to-write code. And so people start thinking, am I doing this right? And they hit Google, and then that's the point at which they see that there's all of these things. This is a small, non-exhaustive list of some of the things that you'll find if you say, what do I need to know to become a web developer? And it's just crazy. And at that point, what happens to a lot of people is they give up. They say, I just wanted to build something, but this is too much. The barriers to entry are too high. And they quit. And it's a tragedy every time that happens. And I've seen it happen time and again. It's a tragedy because those people have ideas that they want to share with the rest of the world. They have ideas that they want to express, and they can't because we've made it too difficult. Now, I believe that the way to break down that barrier is to give people tools that allow them to express those ideas before they understand all the underlying concepts. You should be able to build an interactive web app without knowing about prototypal inheritance, without being able to say what this equals in a particular context. I really believe that. And that's the same as you know, when you're learning French, to reuse that example. You learn how to ask for a cheese sandwich long before you learn about the subjunctive pluperfect tense. And I believe that the people in this room will share that opinion with me. Because when I talk to everyone in the tech industry, everyone sincerely wants it to become more inclusive. Right? We live in a vastly unequal society that's getting more so because technology is a force multiplier. The people who can use technology are going to become further detached from the people who can't. And that's not a situation that should make us comfortable. We as technologists should be fighting that trend. Now, I'm not going to pretend that Reactive is single-handedly going to break down that wall. Of course it's not. That would be delusional. But these are considerations that we on the Reactive team have when we're building the library. We're thinking about whether a new feature is going to help guide a novice user into or away from the pit of success. So here is a short checklist of some of the things that you can do. If you're building tools for other developers, a short checklist of things that you can try and tick off to try and make your tool accessible to people who aren't familiar with whatever your specific domain expertise is. README-driven development. It really works if you write an example of someone using your library before you've written the library. Because then you see immediately, actually, that's a little bit, not sure about that API. It's really hard to change an API once you've shipped. You can always fix your lousy implementation, but you can't fix your lousy API. Do the API first, then the implementation. Eliminate dependencies if you can. Like, don't import underscore into your library just because you're using the extend method or something. If you can't eliminate dependencies, and let's face it, a lot of the times you can't eliminate dependencies, then at least make sure that you serve a version of your library with all the dependencies bundled, because this is one of the main stumbling blocks for people when they're learning a new library, is figuring out all of the dependencies. Don't over modularize. This is a pet peeve of mine. There's a trend at the moment, people releasing new libraries, and like right there at the top of the GitHub README, it's like, this is like this other library, but ours is modular. And the idea is that you've got all of these separate components, and you can kind of mix and match. You don't like this one? Yeah, you just have another one. And in theory, that's wonderful. You just have to write all the glue code that makes all these modules talk to each other. And do you know what? No one cares, right? No one walks into a restaurant and says, oh, I'll have the Cobb salad, but hold the eggs, I've brought my own. It just doesn't work like that. Your modularity fetish is ruining my ability to just use your library. While we're talking about modules though, the universal module definition is a great way to make sure that your library can be used by people who are using Require.js through AMD, people who are using CommonJS through Browserify, but also people who are just dropping your library into the page as a script tag. I really like the universal module definition, and you should check it out. Publish your stuff on NPM, absolutely, but make sure that there are also prominent download links. A lot of times these days, the only way to get a library is to NPM install it, which means that you have to use the command line. And that's a real stumbling block for a lot of people. Make sure you have a download link. Make sure you have good error messages when stuff goes wrong. If you can, use your error messages to link to your documentation. Then you can explain the problem at leisure, you can help people understand the underlying concepts, and you can teach them how to fix it. I said it before, but I'll say it again. Avoid the command line if you can. Beginners find the command line so intimidating. You wouldn't believe it. We're all very au fait with it. We understand how to use it. But for most people, it's just like this, oh, what is that? If you can avoid that, then do. By the same token, if you're building something that would typically employ a build step, try and make it so that the build step isn't mandatory. Right, everything that you can do in Reactive, you can do without a build step. It does support build steps. It has integrations with all of the major build tools. You can pre-compile your templates, you can glom all of your components together, but at no point is anyone ever forced to use a build step. Have examples, loads of examples. Examples are more important than API documentation. I don't want to read your API documentation, I want to see your examples, and I want to copy and paste some code into my app with clear comments showing what everything is actually doing. Eliminate jargon. For the love of God, eliminate jargon. No one should have to learn what transclusion and dependency injection are before they can build an interactive application. I mean, by the same token, no one should have to install a syntax highlighter just because your tool uses a non-standard .js extension. But that's a separate issue. Most importantly, you should empathize. You should put yourself in the shoes of someone who isn't an expert in your specific domain. It doesn't even mean that they're a beginner full stop. Right? I can pass myself off as a front-ender. I know next to nothing about databases. So when you build a database tool that I want to use, put yourself in my shoes as someone who doesn't understand all of the concepts that have gone into that, someone who hasn't spent the last several months thinking about the problem as deeply as you have, and help me get to where you are. Empathy is something that that doesn't often come through in documentation for JavaScript libraries, and I wish it did. So that's basically the end of the talk. Thank you for listening. My message is that we should all want to live in a world where everyone can participate, as I say, both as a creator and as a consumer. And by the way, you should all be using Reactive. Thank you.